Hey class, and welcome back to your pre-lab video for lab number 3. So we're going to jump on in and talk about the different questions here, keeping in mind that these are all just about the part of the lab, which is kind of our at-home version of what's known as the Atwood machine, where you're going to have two masses hooked together with a common string, and you're going to release them from rest. And when one is more massive than the other, they will accelerate so that the more massive one will accelerate downward, while the other one, the lighter one, will accelerate upward. So let's take a look at the pre-lab. As always now, you should have your answers and attempts shown in the left column as you see here, and then the corrected answers that you'll get from this video in the right column. So I'm just going to slide this over just to give us a little more space so that we can try to fit them all here in one go. But this is something that you should be looking at. Now, for the first question, it asks you to draw a free body diagram for the lighter of the two masses. So in this case, there's really just two things that should be affecting your object. One is going to be the upward pull of the tension force pulling up on your object. So you can either use just a T, or sometimes people use F with a subscript T, the force of tension. Either one of those is fine. And then the second force affecting it should be the force of gravity. So it should look something like this. To be a little more accurate, we know that the tension must be larger than the force of gravity to cause it to accelerate upward. So I might make this one just slightly longer. And then something I like to do is I like to kind of off to the side in a different color, make a note to myself that this is the lighter mass, and therefore I know it's going to be accelerating in the upward direction. And for a good free body diagram, you probably want some axes labeled as well. And so you might come on here and kind of go like this and say, we'll call this the X direction and this the Y direction. We can even do the same thing for question 2 if you want X and Y. Now, the free body diagram for the second object, the heavier of the two, if we think about this, well, it should look quite similar. It's going to have a tension force pulling up on it, the force of tension, and then it's going to have a weight force going down. So the force of gravity or the weight force. Keeping in mind, right, force of gravity is the same as a weight force, or a weight force is also just equal to mass times the acceleration due to gravity, which is mass times 9.8. So you could write this downward force or label it with any of those three options. I don't expect you to have all three the way I do, just any of those three. So I wanted to show you those different options. Thinking back about acceleration, once again, the acceleration of block 1 is going to be in the upward direction. The acceleration of block 2, though, is going to be in the downward direction. So this is important to take note of, because at first glance, your free body diagrams look identical for your two objects. And that's because they both just have tension pulling up and weight pulling down. But what's different is the direction that they will be accelerating, which becomes very important, as you'll see as we move on to questions 3 and 4. So now question 3 asks you to do some of the forces for each of the two objects. So we'll come over here just for the sake of space for question 3. So we'll start with block 1. So we'll say mass 1. And we're going to do some of the forces in the vertical direction. So some of the forces in the Y direction equals MA. Keeping in mind, every time you write out some of the forces, I want you to start with that. F equals MA. Some of the forces equals mass times acceleration. So for this, object 1, we have the tension force pulling up. We have the weight force pulling down. So it'd really be plus the weight force in the downward direction, which comes out to be negative weight force, M times G. And that's equal to M1 times A1. And that's a positive A1 because it's up. Now, when you go to do the same thing for mass 2, it's going to look very similar. You're still going to be doing some of the forces. Wow, that's the worst sigma. I'm going to rewrite that. Not that my first one is very beautiful either up here, but oh well. Some of the forces in the Y direction equals MA for mass 2. And now we're going to have the force of tension up minus M2G down equals M2 times, and I'm going to enter negative A2 because A2 is down. So you're going to have tension minus M2G equals negative M2A2. So the difference there is that negative sign. One fun kind of just Pro tip, sometimes people get confused and leave out this negative sign that I've included here. It's one of the most common mistakes I see in physics is forgetting that negative sign. And so what I sometimes have students who have a hard time remembering that do is do some of the forces again. So here's like an alternate method. And what we're going to do is we're just going to define down as positive. So when you go to do some of the forces, you can do the same thing. Maybe I'll just use a different color here. But now down is positive. So you're going to have negative force of tension plus M2G equals a positive M2A2. And if you notice, these two equations are actually identical, but sometimes defining down as positive makes it a little bit easier for people to see. All right, so that's pre-lab question number 3. And now the last question, pre-lab question number 4, points out that if we want to try to solve for anything, we don't know the tension, we don't know A1, we don't know A2. We can measure the masses, which you'll be doing, but you have 3 unknowns and just 2 equations. To remind us which 2 equations I'm talking about this equation here and this equation here, or this one, right? So for pre-lab question number 4, you need 1 additional equation. And the 1 additional equation, some of you may have already figured out already or might be obvious to you. Others it might not. But for question 4, the one thing that we need to observe is that the magnitude of A1 is equal to the magnitude of A2. Since they're both accelerating at the same rate, those 2 values will be equal. The reason I say magnitude is because the directions are opposite. But the key thing to point out there is, again, that since they're tied together, their accelerations will be the same, but in opposite directions. So now that we have that in mind, what we can do is we can just redefine A1 and A2 as the value A, and then we can rewrite our 2 equations so that we have the force of tension minus M1G equals M1A positive, since that's accelerating up. And similarly, we have force of tension minus M2G equals negative M2 times that same acceleration. And now you can put these 2 equations together to solve for T and also for A as the question asks. So if I wanted to solve, let's say, for example, for A, I could solve one of these for the tension force. Force of tension equals M1G plus M1A. And then I can plug that into our second equation. So I get M1G plus M1A minus M2G. Again, this is just FT, so I just plug this in for FT, equals negative M2A. And now we can kind of rearrange this equation. So I have M1A plus M2A. I'm going to move this term over. And then both of these have to switch sign as they go to the other side. And so that's going to be equal to M2G minus M1G. And so to solve for A, you can divide out. So again, this would become A times M1 plus M2. And then that equals, I'm going to factor out the G just for fun, M2 minus M1 times G. And then I divide by this term. And so you get A equals M2 minus M1 G divided by M1 plus M2. One cool thing about this, if you look at this line right here, that's what you would get if you actually just did some of the forces on the entire system as a whole. You'll see that in one of the videos where I talk about doing system as a whole, but that's one way to do it. So anyway, that's our A value. Now to go back and solve for the force of tension, you could actually just plug this in for A over here. I'm going to create a little more space, but our force of tension would just be equal to M1G plus M1A, which is this whole thing. And that whole thing is our A value. So that's an equation for force of tension. It's a little bit sloppy the way I wrote it out there, and you can actually do some distribution to simplify this a little bit, but not a whole lot. So there's our 4 pre-lab questions. I hope that helps you all. If you have any questions, as always, let me know. But other than that, giddy up and have fun with this lab.